Modern humans are ecosystem engineers. We modify our environment substantially, employ tools and fire for protection, clear the landscape by burning it, cook food to improve its caloric value, and encourage the proliferation of plants and animals that are beneficial to us. We also transmit cultural information that allows idea to accumulate past a single generation. The oldest tool use is probably much older than the archaeological record. This is because many animals use and even make tools, suggesting that the behavior well predated us. Second, most tools are perishable, and so the first appearance of stone tools at 3.3 million years ago is probably not a signature of the first tool use per se, but instead an early use of very durable materials. While Homo habilis, which appears about 2.8 million years ago, was named for their supposed first use of tools, the 3.3 million year date on the first hand axes suggests that Australopithecines were the tool makers. Another ecological step in human evolution occurred with control of fire. Fire allows human ancestors to dramatically change the landscape through burning, a strategy that converted Homo into the role of an ecosystem engineer. Fire also has the benefit of offering protection from other animals. And still another advantage of controlled fire is to cook meat or root crops. The earliest record of fire is obscure, but burned stone tools and flakes suggest that Homo erectus used fire to burn the landscape at V54 in East Africa 1.6 million years ago. Cooking foods may well be much younger than this, since currently the oldest hearths where fires were built repeatedly is about 600,000 years old. Richard Wrangham, a paleoanthropologist, has suggested that fire allowed our ancestors to gain much more caloric value from collected foods. Cooking aids digestion of food, and so increases the food value and reduces the amount of food that must be collected to make the same calorie content as raw foods. That's a key point. Wrangham suggests that the increased food quantity and quality spurred the increase in brain sizes, which are metabolically very hungry, with the evolution of Homo erectus about 1.9 million years ago. This date is not that far off that 1.6 million year landscape burning date mentioned earlier, but so far a record of controlled fire like hearths is lacking from this time period to fully test Wrangham's hypothesis. There have been at least 3, and likely more, out of Africa movements of Homo. The earliest is an expansion out of Africa by around 1 million years, and this may have been predated by an earlier migration as early as 1.3 to 1.8 million years ago. Both involved Homo erectus, who made it at least as far as China, and then persisted in the record up to about 200,000 years ago. Later expansions involved Homo neanderthalensis, starting about, say, 400 to 800,000 years ago, and the Denisovians by 550,000 years ago. Homo floresiensis, the hobbits, make it down the Indonesian island chain to the island of Flores by 190,000 years ago. We have no genetic record of floresiensis, so it's unclear whether they are part of one of the earlier waves of migration from Africa, say of Homo erectus, or are a local speciation event, maybe from archaic Homo sapiens. Finally, Homo sapiens leaves Africa about 70,000 years ago based on aboriginal populations in South Asia and Australia. I think it is safe to say that there could easily have been many movements out of Africa for which we currently lack genetic or fossil data. After all, for a while our only record of Denisovians was a girl's pinky bone. Here in San Diego, a mastodon butchery site was uncovered during a highway widening excavation. So Southern California. This is a nice exhibit in the San Diego Natural History Museum on the discovery and the analysis of what's been called the Cerruti site. Dates on a mastodon tusk from the site are a whopping 130,700 years old. The distribution of the bones, damage to the bones, and the presence of flakes off of large hammerstones all make the case that this was a butchery site rather than something produced without humans being involved. If correct, then either the archaic Denisovians, or another archaic group of Homo sapiens, or Homo erectus made it to North America by then. The dating on the Cerruti site pushes humans back in North America to about 115,000 years and suggests that archaic humans made it to North America well before modern humans did. I think this discovery is really interesting because it teaches us to pay attention to evidence for human expansion that may long predate the established chronology. Genetic evidence can also be used to infer the migration history of human ancestors. For several decades, we've known that mitochondrial DNA, tracing the female line, and Y chromosomes, tracing the male line, identify the deepest branches of human phylogeny amongst Africans. Africans are considerably more genetically diverse than any other humans, suggesting African ancestry before, say, 35 to 89,000 years ago. Indeed, most people now say that archaic Homo sapiens evolved by 200 to 250,000 years ago. Mitochondrial Eve, turns out, shows us that the basal root of human females dates to between 140 and 290,000 years ago. In contrast, Y chromosome Adam shows the male root only at 70,000 years ago. The implication of these divergent dates for the first genetically modern men and women is that women produce a smaller but more consistent number of kids than men do, many of whom do not mate at all, apparently, and therefore do not pass on their Y chromosomes. The low genetic diversity of most non-African humans suggests that modern humans are mostly derived from small, founding populations that eventually replaced archaic humans elsewhere in the world without substantial interbreeding. Current estimates have 1 to 4% of European DNA variation from Homo neanderthalensis, and up to 6 to 8% of Papuan genes in New Guinea derived from the Denisovians. In turn, Denisovians appear to have had a small part of their genetics derived from a now extinct ancestor, about whom we know almost nothing, from about 1 million years ago. So, while some humans appear to be willing to mate with just about anybody, breeding between different groups of human species was not particularly common. Homo sapiens spread into Europe by 40,000 years ago, very close to the time of the last Neanderthal populations. Remember that Neanderthals had been in Europe, and before them populations of Homo heidelbergensis, for 400,000 to maybe 800,000 years. As we're learning, Neanderthals had representational art and fairly sophisticated toolkits. At the same time, they had to contend with the predator megafauna of cave lions, cave bears, and wolves as apex predators that likely kept Neanderthal populations small. They were also living during the full glacial period when fluctuations in climate produced a harsh, low predictability environment. Modern humans may have figured in the Neanderthal extinction, but the last Neanderthal may have died out through any number of means, ranging from disease transmission, maybe from us, climate change, or a combination of these variables. Further, Neanderthals had a very high rate of traumatic injury that is likely associated both with their big game hunting ecology and competition with other apex predators, so their ecology may have kept populations low enough that chance events or direct competition with modern humans may have driven them extinct. I bring this up because it's an old feature of human population movements for the new arrivals to replace indigenous species, and this does not always happen through direct violence. Modern humans spread into Southeast Asia on a similar timeline to their arrival in Europe. People moved east into India and Southeast Asia via coastal routes and reached Australia by 35 to 60,000 years ago and New Guinea by 45,000 years ago. There are several waves of colonization in both places after the initial population by Austronesians in Papua New Guinea and Australia. Subsequently, Polynesians reached New Zealand by 1200 AD and Hawaii by 900 AD. Now, modern humans reached Siberia by 27,000 years ago, and then they later crossed the Bering Land Bridge, exposed by glacial low stand between, say, 15 and 20,000 years ago. Widespread toolkits are not known from the main part of the Americas until 11,800 years ago, although initial dates are a little bit earlier, say between 12,000 to 15,000 years ago. American expansion may reflect opening of a passage in the Laurentide ice sheet that once covered all of the northern part of North America in western Canada between 12 and 14,000 years ago. Returning to our genetic tree with the great apes, we can see that our low diversity is a very new thing, the product of the last 30 to 40,000 years of displacement. Until then, humans managed something like the ecology of the other great apes, a lot of diversity that had deep roots. That many groups of archaic humans managed to coexist over the last million years is perhaps owed to their generally small populations and dispersed, often fairly rooted community structure. But this situation collapsed when people began to move around, aided most likely by ever more sophisticated toolkits and perhaps a more permissive climate than the hard winters of the glacial world. For instance, the first agriculturalists to spread into Europe 7,000 to 8,000 years ago are argued by archaeologists to have simply outproduced the local hunter-gatherer populations. Agriculture can sustain much larger human populations despite elevated disease loads than nomadic hunter-gatherer food collection. So there didn't need to be any violence. It was simply a matter of how many kids you produce. In more recent times, where the record is better and we have oral histories, there are numerous examples of one group of humans replacing the locally native populations. The Han Chinese and Mongols both swamped earlier groups. The same is true in the Americas under an onslaught of multiple waves of Europeans. There were, for instance, 200 distinct language groups in California before the arrival of the Spanish, groups that appear to have had deep ancestry stretching back 9,000 to 10,000 years to some of the earliest waves of migration out of Alaska and Siberia. In Spanish California, for example, disease, technology, and reproductive capacity of the Europeans trumped indigenous cultures. The indigenous remnants that were left faced all those same pressures again, as well as outright genocide from American colonizers. If this example has a kernel of truth for other cultural replacements in deep time, then an implication is that toolkits, technology, and cultural organization of archaic humans was repeatedly tested by the arrival of new groups that, in short order, were themselves tested again by later waves of expansion.